Okay, guys. So welcome to today's lesson, lesson 19, Science Prodigy. So, if you are new here, welcome. We have a couple of rules to follow. Always have proper etiquette, which is having good manners, always paying attention, and also you can try to participate in our quizzes, games, and questions. So, how our classes go is we start off with the warm-up. We go over a warm-up. A warm-up is usually a couple of questions from our previous class. We'll review our warm-up, and then we'll move on to today's lesson. You can look at my background. I think we know today's lesson will be on wind and clouds. After the lesson, there'll be a short quiz on the lesson. And after taking the quiz, I forgot yesterday, but now I will say the top score, the person who got 100% on the quiz. And after that, we usually have a demonstration or a game. Today, I have a surprise for all of you. We have a demonstration and a game. And after that, we have a short poll and the class is done. So let's post the warm-up. Okay. Here is today's warm-up. So warm-up 1 is what are the differences between a warm front, cool front, and a stationary front. Warm-up 2 are name 3 different greenhouse gases. What are greenhouse gases and what they do? And warm-up 3 is name 2 differences between weather and climate. Name 5 different climates. You don't have to do every single one of them. You only have to do one warm-up. And also, if you were not here for the previous class or are completely new, you don't have to do the warm-up, but you can try. You can type your answers in the chat. One more thing, starting from today, every one of you, the classes might get a little bit harder because all of your grades will be going up very soon. So to make sure that you guys are not slowing down, you all are allowed to take notes on the classes. Also, by taking notes, you're going to be able to review them when you have a big test on the topic. So now you can take notes on every single session from today. Okay, I'll give you 1 minute for the warm-up. You only have to do one warm-up. Okay, so I think that now that we have enough time, I've given you enough time, let's go over the warm-up. So if you have an answer in the participants, raise your hand, please. If you ever have a question or something, you can, a question or an important comment, in the participants, you can raise your hand. And by raising your hand, it means you know an answer or you have a question. So please raise your hand if you have an answer for warm-up 1. Okay. Kartika, what's your answer for warm-up 1?
A warm front is when a warm air mass and a cold air mass meet and the warm air mass takes over the cold. A cold front is when a warm air mass and a cold air mass meet, but the cold takes over the warm. And a stationary front is when a warm air mass meets a cold air mass, but none take over the other.
That's it. You got it. A warm front is when the warm takes over the cool. A cool front is when the cold takes over the warm. And the stationary front is when both of them meet, but none of the air masses overtake each other. So good job. That was correct and exactly in the way that it was supposed to be said. Now for warm-up 2, name 3 different greenhouse gases. What are greenhouse gases and what do they do? Okay, Tanae, what's your answer? Tanae.
My My answer is three greenhouse gases are carbon dioxide, methane, and carbon monoxide.
I'm not sure about that third one, but you got the first two right. You could have also said water vapor. That was the third main one, but I think that should be okay. So good job. You got at least two, which are 100% correct. I will research on carbon monoxide. I'll get back to you about that one. Okay, good job. But the thing is, what are greenhouse gases and what do they do? Does anyone know how to answer the second part of warm up two? Okay, Aryan, what's your second part of warm up two's answer?
I got the answer that so the greenhouse gases they're the gases in the atmosphere and they warm up the earth.
Okay. Perfect. So you could have also said that greenhouse gases, what they are they are a group of gases that together make up a heat kind of blanket on the atmosphere, which traps in heat from the sun, causing our earth to warm up, and that's called the greenhouse effect. Okay, does anyone have an answer for warm up 3? Anyone? Okay, Swarnika, what's your answer? Oh, you don't have an answer? Okay. Okay, then Shrivant, what's your answer?
I'm not sure if this is right, but
It's okay, you can guess.
yeah. So the difference between weather and climate is that weather is what is right now, but the climate is what happens throughout the day. It tells what happens throughout the day.
Okay, so that's kind of correct. But weather is what happens through the day. It can happen, weather is something that keeps on changing. It can change, it can be different every day. For example, it can be sunny one day or rainy the next day. But climate is the average weather over about 30 years or more. So for example, you could have a mild climate. So 5 different climates we have could be mild climate. We can have a polar climate. We can have a polar climate, which was a cold climate. We can have a tropical climate and we can have a dry climate. So tropical, dry, mild, cold, and polar climates. Okay. Now that we have finished our warm-up, you guys are great. You are getting, I think you guys are improving a lot. You guys have become way smarter than you were. You have learned new topics, so congratulations. Now let's move on to today's lesson. Okay, so our lesson today is on weather and clouds. So let's start off with weather. What is wind? Wind, clouds, sorry, not weather and clouds, wind and clouds. So what is wind? Wind is the movement of air. So you can turn on your fan and you get a gust of wind. But is that cold air or is that warm air? So actually wind doesn't have to be any. It can be any temperature as long as air is moving. So for example, in the desert and there is a desert storm, a sandstorm, the wind might be hot, but it's still wind because it's the movement of air. If you turn on your fan or in a hurricane, it might make the wind cold. But regardless, both of those are wind. It's just that they have different temperatures. Wind is all basic, that the basic definition is that it is the movement of air. Even though we can't see air, we know that it's made up of molecules of different kinds of gases, which are mostly nitrogen and oxygen. When lots of these molecules move, usually in one direction, we call this wind. It's produced by the uneven heating of the Earth's surface by the sun. And since the Earth's surface is made of various land and water formations, it absorbs the sun's radiation unevenly. There are two main factors which are needed to specify wind: speed and direction. So wind can blow at different speeds and move in different directions. Sometimes it even blows in more than one direction at the same time. So how is it caused? So wind is caused by different pressures in the Earth's atmosphere. Air from a high pressure area will move towards an area of a low pressure. High winds are caused when air moves between areas with large difference in air pressure. On Earth, the main differences in air pressure are caused by differences in temperature. As the sun warms the Earth's surface, the atmosphere warms too. So some parts of the Earth receive direct rays from the sun all year and are always warm. That's usually the equator. But other places receive indirect rays, so the climate is cooler, which are usually the poles. Cool air produces high air pressure, and warm air produces lower pressure. Warm air wants to rise, and cool air wants to sink. We learned that in our density lesson. If you were there, we learned that warm air rises and cool air sinks. Warm air always floats on top of warm water always floats on top of cool water. So I think basically we can think that anything that's warm is usually less dense than cold. Anything that's cold. Usually, not every time, but usually. But regarding to wind, when warm air rises, the cool air will move in and replace the warm air, which causes wind. The wind flow. So we can see that wind is caused by air flowing from high pressures to low pressure. And this is influenced by Earth's rotation. So we can see that the wind, we can think of this like a tornado, but we see that this is like a spiral. It goes clockwise, but this is also like a spiral, but it goes anti-clockwise. But eventually it does meet in the middle. So it does change in the middle, as we can see right over here where this middle arrow is and the 1000. Also, we can see that cool air is over land. There's high pressure. The wind direction is towards our right, where there's warm air over land and there's low pressure. So meteorologists use two main measurements to describe wind: direction and speed. Wind direction is described by using the direction that the wind came from. For example, a southerly wind would blow from the south to the north. Wind direction is measured by a number of ways, including weather vanes, flags, and windsocks. Wind speed, the speed of wind, is measured in miles per hour or kilometers per hour. Scientists usually use a tool called an anemometer. Anemometer. We talked about that in our last class to measure the speed of wind. A wind vane is an instrument that determines the direction from which the wind is blowing. An anemometer measures wind speed. The cups catch the wind, turning a dial attached to the instrument. The dial shows the wind speed. And a windsock is a conical textile tube which resembles a giant sock, designed to indicate wind direction and relative wind speed. So in our first one, we know this is our wind vane. In our middle, we have an anemometer, and on our right, we have a windsock. So different types or sources of winds. We start off with our windstorm, strong gusts of wind with no rain in them. Windstorms are straight line winds. This means there is no spinning or rotation like there is in a tornado or hurricane. Wind gusts are sudden bursts of wind, which happen when a cool air from a thunderstorm falls quickly and it collides with the cool, dry air below. When the rain from the thunderstorm hits the cool, dry air, some of it evaporates rapidly. This pushes open a door for the wind and shoves the wind through, making it move much quicker. A jet stream is a fast-moving ribbon of air between two air masses with very different temperatures. The jet streams are always moving from west to east because of the Earth's constant rotation. We have trade winds, which are air blowing towards the equator. Trade winds are always blowing and are always warm. Now we have prevailing winds. The air is almost always moving, at least a little bit. This movement is called a prevailing wind, which prevailing means ongoing. So what are global wind patterns? So global winds, the Earth has consistent wind patterns that when looked from a global scale, global winds are created by both the Earth global winds are created by the spin of the Earth and the differences in temperature between the equator and polar areas. So the spin of the Earth, which creates global winds, this is called the Coriolis effect. You'll learn a little bit more about that in 6th grade. But for now, the basic definition is when global winds are created by the spin of the Earth. These winds are often grouped together as trade winds, easterlies, and westerlies. Trade winds, or tropical easterlies, occur near the equator and flow from either the north or south towards the equator. They curve towards the west due to the spin of the Earth. The Coriolis effect makes the trade winds appear to be curving to the west, whether they are traveling to the equator from the south or the north. Prevailing westerlies. In the middle latitudes of the Earth, between 35 and 65 degrees latitude, are the prevailing westerly winds. These winds blow from the west to the east and are also towards the poles. Of course, we have our polar easterlies. These winds blow close to the north and south poles. They blow away from the poles and curve east to west. So, global wind patterns. The winds in the Earth's atmosphere are divided into 3 main belts. Tropical easterlies are at 0 to 30 degrees latitude. Prevailing westerlies are from 30 to 60 degrees latitude. And polar easterlies are from 60 to 90 degrees latitude. Local winds. Some winds are generated by changes in air pressure and temperatures locally. These winds may change direction as conditions change throughout the day. One example of a local wind is the wind that blows on the ocean coast. During the day, the land heats up faster than the ocean. This causes a sea breeze that blows from the ocean into the land. During the night, the land will cool down faster than the ocean, and the opposite will occur. Warm air over the water will rise, and cool air from the land, called a land breeze, will blow out to the ocean. Land formations such as mountains, valleys, lakes, and deserts can also affect the local wind conditions. So this is a nice diagram which shows both of our land breeze and sea breeze. Okay. So for a sea breeze, this is our land. Okay. So our land is our heat source. I mean, so is the sun. Of course, the sun is our heat source, but it also heats up the land, of course. So if the sun heats up the land, doesn't it also heat up the sea? Yes, it does. And I talked about this a little bit in our last lesson in global warming, that the ocean does take in sun's heat. But if too much of it is taken up, the ocean itself will start heating up. So usually we can think that the land is hotter than the ocean. So warm air rises and cool air sinks. So when warm air rises, the rising air forms clouds. These clouds are also very cold, and the cooler air will sink. This sinking air spreads along the surface. The ocean is cooler compared to the land, and cold sources like the heat sink. And then this wind from the ocean will blow towards the land, which is called a sea breeze. Now we have a land breeze. So in a land breeze, the land cools down because of course it's night. And what happens is that the ocean is warmer. The ocean doesn't change temperature from night to day that much because it is remaining its own temperature. It does stay warm because it is like a heat supply for itself. And of course, warm air rises. The rising air forms clouds just as before. It then becomes into cool air, which then sinks and it spreads across our land. And this land is cool. It's cooled down, the heat sink. So this will then become a land breeze. So I think the most important thing that we can understand is that a sea breeze occurs in the day. A land breeze occurs at night. If a land breeze occurs at the day, then this will be its diagram. Because warmer always rises. And in the day, the land is hotter than the ocean. And of course, that means it'll be a sea breeze. But in the night, we can think of the ocean as warmer. So then the land will give a land breeze out. So that's a good way to explain the sea breeze and land breeze. So how is it helpful to Earth? Wind is the fastest growing source of electricity around the world. It is often one of the least expensive forms of renewable power available. Some experts say it can sometimes be the cheapest form of any kind of power. Generating power from the wind leaves no dangerous waste products behind, and best of all, its supply is unlimited. But what is wind power? Wind power is energy such as electricity that is generated directly from the wind. It is considered a renewable energy source because there is always wind on the earth, and we aren't using up the wind when we make energy for it. The wind is like, we can think of the wind as, so if we have a human on a treadmill, and the treadmill, by us running on the treadmill, it can create a power. So you might have seen those funny cartoons where those people are biking on a bike and it generates electricity for either some kind of wheel or for like a movie. And by doing that, that creates an energy source. So like that in windmills, by blowing the wind, it turns the windmill and that creates energy too. So that we aren't using the wind. We are using the energy the wind gives. By blowing the wind, it causes an energy to be produced. But another big thing is that wind power does not cause pollution. So I think this is very, very helpful. The slide talks about all of its good things. It is extremely good. It is the least expensive form of renewable power, and it is the cheapest form too. It leaves no dangerous waste products behind, and it is unlimited. It is generated directly from the wind. It is a renewable energy source. This is very important because it can be used over and over again because we aren't using it up. And it also does not cause pollution. So no to pollution. Okay. So here's our windmill. Let's talk about how it works. Windmills work because they slow down the speed with the wind. The wind flows over the airfoil-shaped blades, causing a lift. Like the effect on airplane wings, causing them to turn, the blades are connected to a drive shaft that turns an electric generator to produce electricity. Wind turbines and wind farms. So our first one is a windmill, but this is a wind turbine. These ones you can see, if you live in California like me, you must have seen them in the center. We have this whole area full of windmills. There's a couple acres of windmills, they generate so much energy. By how does it work? In order for electricity to be made from wind, energy companies use large windmills called wind turbines. They are called this because they use turbine generators to generate the electricity. In order to create a lot of energy capable of powering thousands of homes, energy companies build large wind farms with lots of wind turbines. They usually build these in consistently windy places, and some companies build wind farms out in the ocean. These are called offshore wind farms. And I think the reason that they are out in the ocean is because, as we talked before, land breezes and sea breezes. Wind energy and wind power. What is wind energy? Wind energy is the process of creating electricity using the wind or air flows that occur naturally in the Earth's atmosphere. Modern wind turbines are used to capture kinetic energy from the wind and generate electricity. How tall are they? Wind turbines are really, really big. The tower itself is typically between 200 and 300 feet tall. When you add in the height of the blades, some turbine towers are up to 400 feet high. The blades are quite big too. They are typically 3 wind blades on each wind turbine. Each blade is usually between 115 and 148 feet long. That is humongous. Okay, so in our diagram, our little diagram here, when you look at the Statue of Liberty, it is really big. But if you combine it to our Empire State Building and our Eiffel Tower, but of course our own wind turbines, it is so tiny. It was super, super tiny. Now, of course, there are some that are onshore and some that are offshore. If we consider our onshore ones, we have our average one, our normal one that we have around our US. That's about 466 feet. But we have the tallest onshore US turbine is 574 feet tall, which is pretty big. But if we go on to offshore, we have our Block Island Offshore Wind Project, which is bigger than all of the onshore wind turbines. It is 590 feet, but our tallest one is our new GE Haliade X, which is 853 feet tall. And that is humongous compared to the Statue of Liberty and the other onshore turbines. Of course, we have our Eiffel Tower that is also pretty big, but it is bigger than all of our wind turbines. But if you look at the Eiffel Tower, you'll realize that it is really big. But for something generating electricity, we have to be pretty proud that mankind has built something as big. And it's not even half, and our biggest one isn't even half of the Empire State Building, which is amazing. It's way bigger. And that's so cool because if we can make them super big, they might be able to generate more electricity. And by doing that, we'll have a more suitable way to generate power. So how does it work? So it works the opposite of a fan. Instead of using electricity to turn the blades to make wind, it uses wind to turn the blades to make electricity. When the wind turns the blades turn a shaft inside the turbine. This shaft is big but turns slowly. The shaft, however, is connected to a number of gears, which causes a smaller shaft to turn much faster. The smaller shaft drives the electrical generator, which generates the electricity that can be used by homes and businesses. So if you see in this bottom picture, this is exactly how a big wind farm is. It is humongous and it can grow, and you can put so many. Imagine how much electricity can be produced by this wind farm in just 1 minute. It'll be enough to power about one home for a couple hours. So if we have a lot of wind farms with a lot of turbines, it'll be better for us rather than using other ways like fossil fuels. So windmills versus wind turbines, what are the difference? Sometimes people use the terms windmills and wind turbines interchangeably, but there are important differences. People have been using windmills for centuries to grind grain like wheat, pump water, and do other work. Windmills generate mechanical energy, but they do not generate electricity. In contrast, modern wind turbines are highly evolved machines with more than 8,000 parts that use the wind's kinetic energy and convert it into electricity. What is a wind farm? Oftentimes, a large number of wind turbines are built close together, which is referred to as a wind project or wind farm. A wind farm functions a single power plant and sends electricity to the grid. How does it come to us? The electricity that is generated from a wind turbine may have to travel a long distance to reach the place where it's needed, like a home or a school. It leaves the generator on a wire and goes to a transformer to step up the voltage for transmission. This high voltage electrical energy is carried across the country through a national network of transmission lines called a power distribution grid or just grid. These transmission lines are seen throughout our country and some are also located underground. Before electricity reaches your home, it reaches another transformer where the voltage is stepped down. This transformer reduces the electricity to 120 volts, where it can operate the appliances in your house, like the oven and your microwave. So this is like a diagram. I think we've all, I think we've seen a couple of these parts. So first of all, this wind turbine, we've probably all seen these before. If not, then maybe you can search it up and look for one near your area. They're really cool. They generate the electricity about 1,000 to 3,000 volts. They step up the transformer and increases the voltage for efficient transport, which is about 155 to 500,000 volts. Transmission lines carry electricity over long distances. And this is something you guys must have seen. These transmission lines. This is found almost everywhere in the world. And these lines are how you can get electricity. For example, you might see them on the highway. You might see them, for example, when you're biking. You might see them when you're in a car. It doesn't matter where, but you're probably going to see them close to a rural area, an urban area, which is not close to a city. Then these step-down transformers at a substation near your house decrease the voltage for distribution for about 10,000 volts. Distribution lines carry electricity to your house, and the transformer on the pole decreases voltage before entering your house. And then the electricity enters your house at about 120 volts, which is still a lot to just be generated from a couple of wind turbines. Okay, so what is good about wind energy? It does not produce carbon dioxide, no cost, it's renewable, and no extra cost. But why is it bad? It's dependent on the wind and an inconsistent factor and often unpredictable, which means that, for example, if suddenly the wind stops for a whole year, then it will be hard to get the electricity. And that's a big con of wind energy. But for example, if you use hydropower, which is water energy, that isn't as inconsistent because you can put it close to a very fast flowing river. And the only time it doesn't flow as fast is probably during the winter where it freezes. But if you go to a river where it doesn't freeze, then you'll have it for the whole year. Solar energy is the third type where you can just keep it out and there will always be sun throughout the year. Throughout the world, usually in the southern hemisphere, if it's winter, the northern hemisphere, it's summer. So at least one part of the world, there will be solar energy. But why else is it bad? It makes noise. It does make a lot of noise and are considered an eyesore. It needs empty plains for wind farms, which are generally located in rural areas, which means it has to travel through lots of wires to enter the city. So you might have to go to a farm or a really rural area where there isn't much, there isn't a big town or there isn't a big city, but it's there because the plains are usually flat or on a hill. So that way they are more elevated and it's more flat so that they cannot tip over, they don't break, and it's more of a consistent area. Also, it has negative effects on birds and air wildlife. There are three main types of wind energy: the utility scale wind, distributed or small wind, and offshore wind. Utility scale winds are ranging in size from 100 kilowatts to several megawatts, where the electricity is delivered to the power grid and distributed to the end user by electric utilities or power system operators. Distributed or small winds, single small wind turbines below 100 kilowatts are usually used to directly power a home, farm, or small business that are not connected to the grid. Lastly, the offshore wind turbines that are erected in large bodies of water, usually on the continental shelf. Offshore wind turbines are larger than land-based turbines and generate more power. Okay, so now let's move on to clouds. Clouds are a large collection of very tiny droplets or waters or ice crystals. These are so small and light that they can float in air. Clouds are made of water, little drops of water. A single cloud can be made of millions of water droplets. We talked about that a lot in our water cycle lesson. But let's not worry about that. Let's worry about the types of clouds. We see them nearly every day. They float in the sky above us and block out the sun. Sometimes they are white and puffy. Sometimes they are dark and cover the entire sky. Different kinds of clouds means different kinds of weathers, and meteorologists study the formation and makeup of clouds to understand the weather better. How do they form? We've talked about that in the water cycle lesson. Most clouds form when evaporation occurs in water, in a large body of water, for example, the ocean. When it's hot enough, it evaporates and the water becomes into water vapor, which is in its gas stage. We remember that heat rises, hot water rises, so the water vapor will rise to a point in the sky where it gets so cold that it turns back into a liquid. When this occurs, it cools down more and more and eventually it becomes a cloud. It is condensed to form a cloud, and why does it float? As long as the cloud and air is warmer than the outside air, it will float. When we see the clouds moving across the sky, they are floating, but they're also being blown by the wind. The clouds that are being moved by the jet stream are moving at 100 miles per hour. The jet stream is a strong wind that blows across the earth. It moves from east to west and is very high up in the atmosphere. Storm clouds move at a much slower speed because they are very heavy, about 30 miles per hour. Now let's go on the main part of clouds. These are very important, and this is where you want to take the notes. So take notes at this part. The clouds are described by the level or elevation where they are formed from. There are the high level clouds, the middle level, and the low level. We also have some vertical clouds. In our vertical clouds, these clouds are very tall and are many of the cloud levels. They usually have the word cumulus. So before I move on to all of these clouds, I first want to say that each level has some kind of prefix or small word in them. So in the vertical level kind of clouds, they usually have the cumulus in their names. They include the cumulus clouds and the cumulonimbus clouds. And both of them have cumul and cumul in their name. Now in the low level clouds, they form below 6,500 feet and are often composed of mainly water droplets. These low level clouds have the word stratus. For example, stratus and stratocumulus. Now we have our middle level clouds, which form between 6,500 and 20,000 feet high. They're made of water droplets or ice crystals and usually have the word alto in their name. For example, altostratus and altocumulus, but nimbostratus does not have alto in it, but nimbostratus is a middle level cloud. Do not forget, because nimbostratus is our rain cloud. Now, lastly, we have our high levels. They have the prefix cirro or cirrus in their name. They are forming above 20,000 feet because it's much colder. They are mostly made of ice crystals. They include cirrus clouds, cirrocumulus clouds, and cirrostratus clouds. So let's remember, high clouds have cirro or cirrus, middle clouds have alto, and low have stratus. Lastly, verticals have cumulus. So this is the perfect diagram. So let's see. We start off with our high clouds. We have our cirrus. This cloud is usually when you can see in the summer, probably when there are almost no cloud, but you see the small light thin cloud layer. Those are cirrus. Those are very, very common. And they are also very nice looking and fun to look at. So those are very common, but you are going to try to make sure that you don't get them mixed up with cirrocumulus or mackerel sky. Cirrus are wispy, wavy kind of clouds. But on the other hand, cirrocumulus is not like that. It has a couple of like dot-like features, which is like a school of mackerel. Okay, we have our cirrostratus, which is kind of like a halo around the sun. Anyways, let's move on to the middle clouds. Now, the middle clouds, our first one is our cumulonimbus. This is a big fat cumulonimbus. It's pretty big. Now, why? Because it can be in all layers, in all levels, but I'll talk more about it in our next slide. Next, we have altocumulus. Those aren't wispy, but they aren't mackerel-y either. They are bigger and more thicker than our cirrocumulus. Next, we have our altostratus, the sun dimly visible. It's kind of dark, but it can be, it's not as dark as, it won't become like a nimbostratus cloud. Okay, next we have our low clouds. So our first low cloud is our cumulus clouds. Our cumulus clouds are usually the common clouds that you draw in your picture of, for example, a garden or a flower. When you draw a cloud in the sky, it's usually a cumulus cloud. This is the most common type of cloud in drawings, and when you think of a cloud, you can usually think of a cloud like that. So there are in vertical development. Next, we have our stratocumulus. Now, our stratocumulus is like the cumulus, but is a little more flatter. Talk more about that later. But now here is our big one. It is our nimbostratus. And I'm going to be using black because it is the rain cloud. It is not the nice kind of rain like drizzle. No, the nimbostratus is like a thunderstorm cloud. It will go very hard precipitation. Okay, so that's where you can find the clouds, how they look. Now, what do they do? I'm just going to go over it quickly. Cirrus clouds are high level, thin and wispy, and they appear in good weather. Cirrocumulus are high clouds that look like tiny cotton balls bunched together. Cirrostratus are high flat clouds that might cover the sky, making it appear overcast. These clouds signal it might rain in the next day. Altostratus is medium level clouds that form a dark gray covering. Usually they are a sign of rain, but not raining. Altocumulus clouds are middle level clouds that are small, puffy and white. Nimbostratus clouds, those are the thick, dark gray middle level to low level clouds. They usually bring the rain and snow. We have our stratus clouds. They are the low level clouds that are flat and tend to cover most of the sky, but they are gray in color and they may produce a light rain or drizzle. Now, nimbostratus is rain and snow, but it's heavy rain. You have to remember that stratus is a very light rain and drizzle, different than the nimbostratus. The stratocumulus are low, puffy gray clouds. They may produce a very little rain, but they can turn into a nimbostratus. So we can think of our main rain clouds are nimbostratus and stratus clouds. Our cumulus clouds are low to mid-level clouds. They're big, white, and puffy, but they are very beautiful. They usually mean good weather unless they grow really tall and turn into cumulonimbus clouds. Lastly, we have our cumulonimbus. Those are very tall clouds that span all the way from low level to high level. They can cause violent thunderstorms with heavy rain, hail, and even tornadoes. Now we're just going to talk a little bit about fog and we're done. Fog is mist when it is very thick. It may appear on land or sea. It lowers visibility and makes it hard to see far. It creates a cloud called stratus. There are many types of fog, such as evaporation fog, advection fog, radiation fog, and upslope fog. And its thickness depends on the atmosphere, temperature, weather, and location. Radiation fog forms in the evening when the heat absorbed by the Earth's surface during the day is radiated in the air. It is also referred to as the ground fog. Our advection fog forms when warm, moist air passes over a cool surface. The process is called advection, a scientific name describing the movement of fluid. In the atmosphere, the fluid is wind, and it shows in most places where warm tropical air meets the cool ocean air. Next, we have valley and freezing fogs. Valley fogs form in mountains, valleys, usually during the winter. And freezing fog happens when liquid fog droplets freeze to solid surfaces. Mountaintops that are covered by clouds are often covered in freezing fogs. As the freezing fog lifts, the ground, trees, and even objects like spiderwebs are blanketed by a layer of frost. There are our 4 types of fog. We have our warmer air, our radiation fog, we have our advection fog, we have our upslope fog, and our evaporation. Okay, so that was the lesson today. So now I will pause. I will stop sharing my screen and I will post the link to our quiz in the. Okay, guys, let's go over the quiz. So I'm going to share my screen. Okay, let's see. So we are class. So what is wind? Wind is the movement of air, not cold air or warm air. Windsock is used for both to determine the wind speed and the direction. A wind vane, though, is only used for the direction. Sudden bursts of winds are called wind gusts. Trade winds are also known as tropical easterlies, which cannot affect local winds. Remember, all landforms, mountains, lakes, and deserts, not the ground. Land breezes, they occur when in night. Which breeze is from land to sea? The answer is also a land breeze. Okay. Why do people use wind power? Because it's renewable. There is no pollution. Power is more reliable. We don't have to use up all the wind. It is the cheapest and it does not leave any waste products. Select one middle and high level cloud. I'm sorry about that question. You can choose one random one. I'm going to go with the nimbostratus. Thick mist is also known as fog. Which flat cloud is the light rain cloud or the drizzle cloud? And that answer is our stratus cloud. So let's make sure we've answered everything. Okay, then let's make sure we got 100%. Okay, good job, all of you. Now I will also say whoever got 100% on the quiz. Let's see. Okay, let's see. I have stopped the screen sharing so no one else sees other people's score. But we did get a couple of 100%, so good job, you. Okay, so our first person to get 100% is Kartikeya. Congratulations and good job. Our next person is Prajit. Good job, Prajit. You got it twice. Congratulations. And our third one is Shrinika. Good job, Shrinika. So congratulations to those 3. This was a hard test, but you guys pulled through and all of you other people did get pretty good scores. So I congratulate all of you. Anyways, now let's move on to our demonstration. So I will stop my background so you guys can see. what we're doing today. Okay, let's see. So today we're going to be showing how you can make your cloud in a bottle or a can. I'm going to use a jar because it is see-through so we can see our cloud. So to start off, you will need some hot water, some ice, and some hairspray. Now I didn't have any hairspray, so I'm using some men's deodorant, spray-on deodorant. But if you do use any kind of aerosol that is flammable, do not make your water boiling hot. Just make it warm. So how this is going to work is we have to be quick with this. We're going to pour our hot water into. So we're not going to pour too much, just about a little bit. Sorry, about 1/3 of it. Now we're going to just spray in a little bit, and we're going to quickly close our lid. Tighten it up, and we're going to put our ice on top. Now, why do we put our ice on top? So what happens is our water here is hot water, and our ice here is cold. So if we remember our water cycle, we remember that when water is really hot, it turns into water vapor, thus rising up. And when it does hit our ice here, which is a cool temperature, it will cool. And then because it is colder than the surrounding temperature, it becomes a cloud. Now, why did we use aerosol? Because if you do not use aerosol, then what will happen is when it will heat up and become water vapor, it will condense, but instead of condensing into a cloud, it will condense into water droplets. And this water droplets won't be able to get together. So instead of getting together, they'll just fall back to the ground because their temperature will be hotter than, colder than the outside. So they have to be warmer than their outside temperature, which is used by this aerosol. Okay, now if we just take a look at it, we can see that we have a cloud inside. But now this is a really, really cool part. When we open it, so as soon as we open it, you guys will have to watch really carefully, but we will have a cloud that comes out. Did you all see that? See, some of this cloud is coming out. Right now, it is partially cold, but it is warm because we didn't let it cool down enough. So I'll just, okay, there, we should be able to see a lot of this cloud. So you can try this at home, but if you do use some flammable aerosol, be sure to have parent supervision and make sure that your water is not too hot. Okay, so that's our cloud in a bottle. That's really cool, especially that we can see our cloud is coming out. So now if we think about it, we have our cloud in our bottle, but if this is coming out, why? Because remember, gas molecules take up as much space as possible. Also, we have it cold out here, and it is pretty warm inside here. Okay, so that was our cloud in our bottle. Now, let's play the game you all play. Okay. So here is today's game. I will share my screen to the game. So how this game works is I will show a picture of a cloud. You have to guess which cloud it is. I will give you 4 options. So our first option, okay, let me just make sure. Our first picture, type your answer in the chat. What cloud is this? I will give you 4 options. Your choices are cirrocumulus, stratocumulus, cirrus, or cumulus. Yes, almost all of you got it correct. It is cirrus. This is our cirrus cloud. It is a wispy kind of cloud, our thin wispy cloud in our high area. What about this one? I will give you 4 choices. Altocumulus, A. B. Nimbostratus. C. Cirrocumulus. And D. Cirrus. Ooh, we have a couple of mixed answers. Ooh, okay. So, okay, you guys are getting it now. The answer is C, cirrocumulus. So congratulations on those who got that correct. Let's go on to our third picture. A, cumulonimbus. B, nimbostratus. C, cumulus. Or D, cirrus. Okay, so, okay, if you want me to repeat, I'll repeat it once. A, cumulonimbus. B, nimbostratus. C, cumulus. Or D, cirrus. Yes, it's B, nimbostratus. It is our rain cloud. What about this one? Your choices are A, altocumulus. B, cumulus. C, stratocumulus. Or D, cirrocumulus. Ooh, we have a couple of mixed messages. But a couple of you did get it right. It is A for altocumulus. What about this one? What is this one? A, nimbostratus. B, stratocumulus. C, cirrus. Or D, cumulonimbus. D, cumulonimbus. Now, if we look at it, we can see it's humongous. It's a tall cloud. What about this one? A, cumulus. B, stratocumulus. C, cirrocumulus. Or D, altocumulus. If you're getting a couple, I don't think many people got the right answer, but a couple of you did. It is our stratocumulus, not our cumulus and not our altocumulus. It is our stratocumulus. This is our last cloud of the day. Which one is it? A, altocumulus. B, cumulus. C, cirrus. Or D, nimbostratus. D was nimbostratus. Ooh, a couple of you guys are getting it wrong. Our answer was cumulus, not nimbostratus. It's a cumulus. It's not D. Okay, it's not D. It is cumulus. So that was today's lesson, and that was today's game and demonstration. So once again, thank you everyone for joining. I totally appreciate you guys coming, and I hope you guys join me next week. So goodbye, you are free to go. I will post the poll right now. Goodbye.